Welcome to Significant Figures in Calculations. This video is part of a series in Foundations of Engineering by Conceptual Calculus. This video assumes that you understand the meaning and purpose of significant figures. You can determine how many significant figures a given value has, and you can round a value to a desired number of significant figures. If not, then please first watch our video Introduction to Significant Figures, work the examples, and then come back to this video. In a previous video, I described pacing my driveway to find that it was 31 yards long. Then I converted that to meters. The result appears to give the length of my driveway to the nearest tenth of a millimeter. That's nonsense, of course. I can't know the length of the driveway to the nearest tenth of a millimeter just from pacing it. What can I know? How many of the digits carry meaningful information? Because my measurement of 31 yards had two significant figures, the result is accurate to two significant figures, so I round to 28 meters. The number of significant figures in the result of multiplication and division is the smallest number of significant figures in any of the factors. Here's another example. Find the circumference of a circle with a radius of 2.34 inches. Round to an appropriate number of significant figures. To get the circumference, we multiply 2 times pi times the radius. How many significant figures do we want? The 2 in 2 pi r is an exact value. We treat it as having infinitely many significant figures. Pi is also an exact value, but I did not type infinitely many decimal places into my calculator. I used only 6 significant figures of pi. The given radius has 3 significant figures. Taking the smallest of those, we conclude that our result has 3 significant figures, so we round it to 14.7 inches. Now you try one. Pause the video, work the problem, and then restart the video to see how you did. Welcome back. The area of a rectangle is length times width. How do we round that? 121 has 3 significant figures. 57 has 2 significant figures. The smaller of these is 2, so we want 2 significant figures on the result. The area of the field is 6,900 square meters. Now try another one. Pause the video, work the problem, and then restart the video. Welcome back. We have speed in miles per hour, and we want to put it into miles per minute. We use a conversion factor to get from hours to minutes. Canceling the hours leaves our result in miles per minute. 571 divided by 60 gives us 9.5166 repeating. Now we consider significant figures. The given speed has 3 significant figures. 60 minutes per hour is an exact value. Exact values have infinitely many significant figures, so the smaller number of significant figures is 3. This means we want 3 significant figures on our result. The speed of the plane is 9.52 miles per minute. Next, we consider addition and subtraction. The Field Museum of Natural History in Chicago has a fossilized Tyrannosaurus rex named Sue, after Sue Hendrickson, who discovered the fossil. Paleontologists determined that the fossil was 67 million years old, and that the dinosaur had been 28 years old when it died. Does this mean the dinosaur hatched 67,028 years before the fossil was found? The age of the fossil has 2 significant figures, indicating that paleontologists determined the age to the nearest million years. The fossil is between 66.5 million and 67.5 million years old. On that scale, 28 years is insignificant. So, what do we really know? Sue hatched 67 million years ago, lived for 28 years, and died 67 million years ago. It makes no sense to add 28 years to a number that is accurate only to the nearest million years. When adding and subtracting, round the result to the rightmost column in which all terms have a significant figure. For example, we want to add these three numbers. How many significant figures do we have? All quantities have significant figures in the hundredths column. If we move farther to the right than that, we will not have a significant figure in the middle term. We round our result to the hundredths place. Now you try some. Pause the video, work these problems, and restart the video to see how you did. Welcome back. First, we add the numbers. Then, we look for the rightmost column in which all quantities have a significant figure. It is the hundreds place. If we go to the right of that, the first number does not have a significant figure. That means we want to round our result to the nearest hundred. The subtraction problem has a bit of a twist. First, we subtract. Then, we look at the significant figures. The top number has a significant figure in the thousandths place, with zeros to the right of that, so we round to the nearest thousand. That gives us our original number back. Subtracting 56 from a number that is accurate only to the nearest thousand is like adding 28 years to the age of a 67 million-year-old fossil. It has no significant effect. Finally, we consider problems involving more than one operation. Remember to keep all available digits during calculation and round only at the end. First, we perform the addition and subtraction inside the parentheses. This gives us three numbers to multiply together. Now we look at the number of significant figures. When we did the addition and subtraction, all values had a significant figure in the tenths place. The first two also had a digit in the hundredths place, but the last one did not, so our result is good only to the nearest tenth. That gives us three significant figures. We look at the other two factors in the multiplication. The first has 4 significant figures, and the second has 2. The smallest of these is 2, so we round our result to 2 significant figures. This gives a result of 3,300. Now you try one. Pause the video, perform the calculations and round the result, and then restart the video to see how you did. Welcome back. Following the correct order of operations, we do the multiplication first and then the addition and subtraction. Next, we think about the significant figures. The numbers we multiplied had 3, 2, and 3 significant figures. The smallest of these is 2, so we have 2 significant figures on the result of the multiplication. Moving on to the addition and subtraction, the first 2 numbers in this step have significant figures in some of the decimal places, but the result of the multiplication is significant only to the nearest whole unit, so that is how we round the result. I hope this has been helpful. Conceptual Calculus thanks VIVA, Virginia's Academic Library Consortium, and New River Community College for their generous support.